All right, guys, so this is going to be part 3 here. Hopefully I'll keep this one short. These questions aren't as too big, okay? We know what the graph of f of x is equal to the absolute value of x. We know what that looks like, okay? That's the v function or the absolute function, right? So we know that there is it intersects at the origin, and we always have a value of 1, 1, 2, 2, so on and so forth, right? Negative 1, 1, negative 2, 2. So we know what this graph looks like. Okay, this is just one of these 5 parent functions that you would have been introduced to in grade 11 functions, right? Along with sine and cosine and root x and all those guys. Okay, so what we want to do here, though, is we know f of x can take on 2 things, right? And it can take on, it's almost like a piecewise function almost, right? We can take on like values of negative x, and we can also take on values of positive x, right? And then we know, right off the bat, we know that if I were to take the derivative of this, we know that it's going to be, oops, not too good at drawing those, negative 1 and 1, okay? Now, if x is less than 0 here, we know, I guess we're interested in x is less than 0, and 0 and x is greater than 0. We know when x equals 0, the function itself is going to be at 0. And then for everything left of 0, we know that it's going to be in the positive, and we also know that it's going to be in the positive for x is greater than 0 as well, right? The function itself, right? We can see that here. It's all positive, all positive. Now, the problem is, you might think, okay, well, you know, if I were to take the derivative here, you know, we've got a negative slope here, and we've got a positive slope here, so that must mean that this is a minimum, right? Well, it turns out that we can't actually take the derivative. Like, there's no derivative of this function, right? So f prime at 0 does not exist, and that's because it's a point, right? It's not this isn't necessarily a smooth curve where the derivative actually goes to 0. This is like one of these undefined points. Like, there's no slope here, right, at the origin, right? So we can still say that it's a minimum, but its derivative does not exist. Okay, so we can say 0, 0 is a critical value, and we know it's a critical value because of this changing in the slopes, right, from negative to positive. But it's the only thing that's true is that the derivative does not exist here, right? We can't derive that function at that particular point. Okay, so critical value, I'm getting all spaced out here. Critical value, that's a local min. Okay, bit of a unique situation here, right? These last two are kind of unique situations, right? And they're a little bit shorter in terms of question-wise. Okay, the last one here, these are 2 unique situations where we have minimum or critical values. We have critical values, but they're unique critical values. Okay, this one here is undifferentiable at x equals 0. Okay, this one here is unique as well, and we're going to see this. You guys have seen this function. This is a cubic function, right? So again, we know what this looks like. Okay, but something interesting happens right in the middle of the cubic function, right? So we know we could derive this to be f of x. This can still follow the same procedure, right? Where it's 3x squared, right? And then for the critical points, we want to set this equal to 0, right? I guess we could make that points. We could set f prime of x is equal to 0, and so we're going to see 3x squared is equal to 0. right? And so we're going to see x is equal to 0 as the critical point here, right? So we know, so let's look at the behavior around x equals 0, right? So we're going to have everything x is less than 0 and x is greater than 0. Okay. If I were to plug in 0 into the original function, I would get 0. So we know that's one of the points, okay? And you guys know how this graph looks, right? If I were to plug in 1, I would get 1. And if I were to plug in -1, I would get -1. Right? And then if I plugged in 2, I would get 8. And if I plugged in -2, I get -8. So there's your cubic function. You know this already, right? Comes up, goes through here, and comes up. Okay. The interesting part about this particular function, x cubed, is the fact that along every interval on this graph, the derivative is going to be positive. Right? So what's this leave then? Right? Well, these we're going to look more at what these are later, right? But for the purposes of this lesson, we can just say it's a critical point, right? There's something going on there, right? So you can at least say that. Okay, this is a nice transition into this afternoon's lesson, right? It's a critical point, but it's neither a max or min. And hopefully that's a curiosity point for you heading into this afternoon's lesson. Sorry, I'm talking max or min. Okay, so hopefully this point here in this particular graph leaves some intrigue around, what is it then, right? Because we can see that there's no change in slope on either side of the on either interval, but obviously something's happened here. So we're going to talk about what that actually is a little later. Okay, and these are cool points. Okay, so this is a good couple transition point questions here, heading into kind of wrapping up what we did in this lesson and transitioning into this afternoon stuff.